Good day everyone, I am BLASABAS from grade 12 Newton. So today I will be discussing about elastic and inelastic collisions. This presentation aims to explain the concepts, laws, and real-life examples related to these types of collisions. So by the end of this lesson, you are expected to first define and differentiate elastic and inelastic collisions. Second, explain the laws of conservation that apply to both types of collisions. And third, compare real-life examples of elastic and inelastic collisions. To begin, let us define what a collision is. A collision occurs when two or more bodies exert forces on each other for a short period of time. This happens in everyday situations, such as when two cars bump into each other or when a ball strikes a wall. During a collision, energy and momentum are transferred between the colliding bodies. There are two main types of collision, elastic and inelastic. These classifications depend on whether or not kinetic energy is conserved during the interaction. In an elastic collision, both momentum and kinetic energy are conserved. This means that the total kinetic energy before and after the collision remains the same. Objects involved in an elastic collision bounce off each other without undergoing any permanent deformation or generating heat. A common example of this is the collision between billiard balls. On the other hand, in an elastic collision, momentum is conserved but kinetic energy is not. Some of the energy is transformed into other forms such as heat, sound, or deformation. An example of this would be a car crash, where the metal body of the vehicle becomes deformed and some energy is released as heat and sound. Another example is when two clay balls collide and stick together. To summarize, in elastic collisions, both momentum and kinetic energy are conserved, and the objects bounce apart, while in elastic collisions, only momentum is conserved, and the objects may stick together or become deformed. Thus, the main difference lies in the conservation of kinetic energy. Let us look at some real-life examples. For elastic collisions, we can observe them in gas molecules colliding, or in billiard balls striking each other. For inelastic collisions, examples include meteor impacts and car accidents. These examples help illustrate how the principles of collision apply in both small-scale and large-scale events. In conclusion, collisions play a significant role in understanding the laws of motion and energy. In elastic collisions, both momentum and kinetic energy are conserved, while in an elastic collision, only momentum is conserved and some energy is transformed into other forms. By studying these concepts, we can better explain real-world phenomena such as car crashes, bouncing balls, and even molecular interactions. Thank you for listening, and I hope you have gained a deeper understanding of elastic and inelastic collisions.